got Bill Rapp, who is an IBM Distinguished Engineer and Chief Architect of Watson for Healthcare. And then we also have Dr. Paul Grundy, who is the Director of Global Healthcare Transformation at IBM. And so they're going to be talking about IBM's Watson, and I'm going to let them take it away.
Okay. Thank you. Welcome, everyone. What we're going to do today is I'm going to give you a quick overview of Watson, where we are with Watson. And then I'm going to ask Dr. Grundy, to give us his view in talking with physicians and others around the country of where Watson can go in the healthcare industry. And then at the end, I'm going to take us through a demo here of one of the applications we have of Watson, which I think you'll find interesting. It's a collaboration we have with Memorial Sloan Kettering in cancer oncology treatments. So I hope you'll find that interesting, and then hopefully at the end we'll have some time for questions. So first, let me try to position Watson in this new era of cognitive computing, and this really is a new era. It's something as important as where we started out in early 1900s with tabulating systems, and then the programmable system area that started in 1950s and have been going strong and will continue to grow strong for quite some time. That era, the programmable system era, is characterized by being able to take information, being able to cleanse it, curate it, slice it and dice it and make it something that's very precise. And it's also characterized by programmable systems that are using that data and very precisely giving you answers to questions or showing you information. So there's a lot of work in pulling that together, a lot of time and labor of taking that data, curating it, and putting it into something that's useful for these programming systems. But all of that is predetermined in terms of how you're going to use that data and what kinds of questions you're going to be asking that. This new area of cognitive computing deals with the problem that we're dealing with today, which is 80% of the world's data is in a format that's been unusable by traditional computing systems. And we're working with large amounts of what we're calling big data, and we don't know what kinds of things people want to do ahead of time. We can't come up with all the different variations. We can't pre-program this information. People want things, different people want different things, and they want it now. So cognitive computing is what we're using to address that. As I said, what's driving this is this whole era of big data. And we all know that big data is high volume data. Just the massive amounts of information is beyond what traditional computing systems, and also the velocity of information, the speed at which this data comes, especially as we start to getting sensor data, social data, and those types of things that require a whole different approach to doing this. And then the variety of data, the fact that this data is not in one form. It's certainly not pre-curated, sanitized data in rows and columns and database tables and things like that. That's certainly part of it, but a lot of it now is unstructured data, it's video, it's audio, a whole variety of data that's needed to come up with the types of decisions that we need. And then most importantly is the veracity of data. And this is what really ends up driving the need for cognitive computing, is that as we pull in this data, not every piece of data is created equal. Not everything is as high quality as any other piece of information. There's all kinds of uncertainty in the data. There's inconsistencies, ambiguities, and things like that. All that's got to be worked out. In the traditional programming days, all that was worked out ahead of time. You'd have an army of IT people going through and curating that data and fixing it up so that you can get specific results. In this world where the information is coming in faster and there's more than what we can process ahead of time, all that information has to be, quote, curated on the fly. So it requires a whole different approach to computing where we can't rely on precise ways. In fact, cognitive computing is characterized by probability. So what we want to do is, as we analyze that data, we do the best we can to filter it, to quantify it, to figure out what the quality is. And then we give a probability. We find the answers, we look through the data, we look at what the preponderance of that data leads us to, what kind of conclusion it leads us to, and then we give a probability of this being right. And depending on what's being asked, the answer may be, I am with almost certainty that this is the right answer for this. To there's not enough data in this corpus of information. The answer you're asking is not really addressable, or the quality of data that deals with this area is not something that we can rely on. So the idea of cognitive computing is it gives you that information back. But that's what's required in order to be able to use this massive amounts of information that people are dealing with in the big data era. So that's what's driving this, and that's what Watson is all about, is trying to address that. For those of you who watched the Watson play Jeopardy back in February of 2011, you might have been interested in some of the information that went out there. But back then, this was something that the IBM research organization put together specifically to play the game of Jeopardy, which for those of you who don't know, it's kind of a trivia type of question, but requires deep analytics to be able to answer those types of questions. But that game required 2,800 cores of data, supported one user, and basically took on questions that were a single sentence. By 2013, we've got that down to, so it runs now on a single multi-core system, a single power system. We can have thousands of users, multiple pages of input. And now in 2014, as we start to roll this out in commercial areas such as healthcare, our goal is to be able to make this available as a cloud service. So everything we're doing with Watson is going to be available as a service. You don't necessarily buy a Watson to put in your site. You subscribe to Watson as a service, so it's basically available to anyone. But that way we can expand it, we can support millions of users, we can have dialogues and things like that. So that's where the technology, it's moving very fast. Technology, our optimization of this is made it so we can start bringing Watson to the masses. Now, there's three classes of service that we're finding people wanting to use Watson for. Number one is the traditional, what we call the ask service, where a user has a question and we use Watson. This is the Jeopardy example. Think of it as Siri on steroids or something like that, where you're asking a question, it's a very concise question, and you want Watson to give you the answer. Certainly Watson does that well. That's being able to characterize whatever information is in your corpus, in your company or outside the company or whatever, give you specific answers. And Watson does that very good, and again, with the idea of cognitive computing, you can basically ask it anything, and it will tell you what its confidence in that answer is. The second area is, I think, probably more important, which is the discovery service. So in this case, think of the user being a researcher. And the researcher isn't asking for questions. If they wanted that, they just get the ask service. So think of a researcher just saying, what genes are associated with breast cancer, for example. I mean, Watson can give you that type of answer. But in a discover environment, you want to know, you're asking things like, well, I'm doing research on leukemia. I'm looking for new drugs that might be appropriate for leukemia. Maybe I want to find out what drugs are used in breast cancer that could also be used in leukemia, in treating leukemia, that aren't used today. Well, now I got to start looking at what are the similarities, what's the information about breast cancer drugs, what genes do they target, what proteins, what kinds of things do they affect in the body that might be similar to my leukemia patients. So now I'm not interested in Watson giving me the answers, because the answers aren't necessarily there. I mean, you can't ask Watson what breast cancer drugs are going to work for leukemia, because you don't have that information. So in a discover environment, you're looking for, don't show me the answers, but show me all the evidence. Show me all the passages, show me the documents. And again, expanding my search so Watson is thinking of things that maybe I forgot to ask, or I don't know exactly how to even state my question. So I want Watson to expand the terms of my query or the information that I'm asking. So it's giving me feedback of things that I might be interested in. So my initial question might not have anything to do with the final question that I'm going after. So that's the discover phase. And then the decide phase, the decide service, is what I want to demonstrate today, and something that is more relevant to what we're doing in the healthcare field. And this is using Watson, again, to answer a specific question. But in this case, the question is preset. What diagnosis does this patient have? What treatments should this patient have? So it's a very simple question, but the amount of information that goes along with that question is all the information about that patient, their history, their lab tests, their genetic makeup and things like that. So analyze everything about this patient. Show me what their signs and symptoms are. Show me what diseases they might have. Show me what treatment options might be best. In a decide environment, what we're looking for is precision, because we're working with doctors who want that level of precision. So we have to build that in, so it's not just using a single type of information, it's combining multiple pieces of information. So yes, we'll use information that's in a corpus of information, textbooks, journals, clinical trials, and things like that, but also taking into account the knowledge that the physicians have in their head, taking into account the historical cases that they have, feeding all that information into Watson, validating it with the physicians, and training Watson to come up with answers the way a top oncologist in the country would do. So that's what I'll be demoing here in a few minutes in a collaboration that we're having with Mayo Clinic. But basically think of this as doing whatever it takes to get the best answers and to be able to have Watson respond similar to the way of a physician. And maybe it's like having a physician colleague with you in your doctor's office or with the patient. So those are the three areas of cognitive services. And one of the areas that we're most focused on is healthcare. It's the first area that we went after because of the huge opportunities there. So I'd like to ask Dr. Grundy here to give us his perspective on the use of Watson in the healthcare environment.
Thank you very much, Bill. From a point of view of a physician, 20% of our diagnoses are wrong. And they're wrong for multiple reasons. And I guess the question that we ask is, what will a tool like Watson, cognitive computing, do to take away the pain of us trying to do the right thing for our patients and trying to manage a population? So what Watson fundamentally is going to do for our minds what imaging and x-rays have done for our vision over the last 20 or 30 years of my career. It's going to make it much clearer kind of what's going on in the system. A couple of examples. I sat with the physicians working with a specific patient, Memorial Sloan Kettering. And the patient's coming in as a referral, and she had 300+ pages of data and information. So Watson was presented that data and information, and with natural language processing and parallel computing, it sorted through that data pretty much at the point of care, right? I mean, it could do that pretty efficiently and effectively. It took a fellow who was studying to be an oncologist a week to develop that level of clarity and be able to really sort out exactly what was happening in that data. So the second thing that Watson did was it went out and it banged up against the entire corpus of literature that had ever been published about that particular form of lung cancer with the patient's data, and then banged it up against a bunch of patients who had a similar disease process from Mayo or Memorial Sloan Kettering or others that are Cleveland Clinic, or others that are working with us, And then on a pretty simple format, gave information with probability and with a drop down that the doctor could look at, which would be, what's the most likely thing this could be and what's the most likely treatment. It just made it much easier and clearer for the doctor to do that. So one of the pieces of advice that Watson recommended, looking through all the literature, was some tests that perhaps could help clarify further the information. One was to look at the genomics of that specific cancer, i.e., what's making up the genetic difference between normal tissue and that cancer. That was done, right? And that's doable now. So Watson then went back out and looked at the corpus of literature that happens in healthcare, and it pulled back a recommendation that a specific drug had the highest probability of giving this person the right treatment. And the drop down on that was from a paper that had been published 2 days earlier in an obscure Israeli journal that had specifically looked at the genomics of that tumor and how that tumor was impacted. So when I talked to the docs and I asked the docs, what would that take as a human being? They say it would take a lifetime, right? It would take a lifetime to sort that out. So that's why I think it'll do that. So the second most common cause of errors, the first is another issue, is that we just simply admit stuff that we don't, because we don't have the time. We don't have a week to look at every chart that comes in. And a case in Australia that I was involved with was a simple case of somebody who had inflammation in their joints, inflammation in their eyes, and the diagnosis of Reiter syndrome was made, which is a likely diagnosis. But Watson suggested with a much higher degree of probability that it was Lyme's disease. And when you look through what happened there, was the patient actually had indicated in their records that they had gotten a master's degree in New England, and so the doc should have asked the question, where did you live? And it is possible you have Lyme's disease because you don't see it in Australia. But that was simply admitted, and that's a very common human error that we make as physicians. So I think that we think of this as just profoundly powerful clinical decision support that's going to make a huge difference. And fundamentally, that transformation will do to the doctor's minds, again, what imaging has done for the vision, but no longer are we going to be data storage repository units. So the last thing I'd like to talk about is the siloization of healthcare, right? So as healthcare has gotten more and more and more complex, we've siloed down into deeper and deeper views of that, and we've reached a point where we're unable to communicate vertically what's happening with the patient because they're being seen here by one group. One of our colleagues, who's a researcher at Watson, took their own human dilemma, which was severe asthma and gastric reflux, and put that into the Watson tool. And Watson came back and said, I think, with a high degree of probability, that if you treat that underlying GERD, the hiatal hernia that should be repaired, your asthma will also go away. And by the way, it did, right? So it was just the fact that, you had somebody treating asthma, you had somebody treating, and nobody ever put it together that they were actually related. And that's another very common human error. So I think they'll enjoy the demonstration.
Yes, very good. I like your comment on no longer is the human the data silo. I mean, we've gone from the doctor keeping all that information in their head, in some cases a group of doctors keeping this information in their head. That's how medicine's been practiced for decades, but the amount of information is way beyond what any single doctor or group of doctors can handle anymore. You need something like that.
To that point, we're the last industry in the world that's still a master builder. I mean, we still treat patients at the bedside the way a master builder would have built a cathedral in the 1400s in the construction industry. There's no accountability for the fact that somebody understands the tensile strength of steel and the expectation that every time a construction project happens, that the tensile strength of steel will be understood by the doctor because the human dilemma of health is so much more complicated than banking or construction or tourism, and it doesn't respond to rules-based computing. And I think the next step is really cognitive for us.
Exactly. All right. Next, I'm going to give you a little demo here, probably 5 minutes of what one of these applications might look like. This would be the decision application. This is something we're working with Memorial Sloan Kettering. Don't worry, these patients are fake patients. So you're not seeing any information you shouldn't see. But what I'm gonna click on this patient here, which is a breast cancer patient, and it's a combination of structured and unstructured data from the patient record. We're going to submit that information off to Watson. This is running back in our labs in Minnesota right now. Hopefully they're not messing with my machines back there. And it's coming back with the summary of this patient. So first thing we'll notice on the left side of this is we know that we're dealing with oncology. In fact, we know we're dealing with breast cancer. So we're not looking at everything about this patient. Watson only wants to know the relevant facts about a breast cancer patient. And that's what you see here, the summary of some of those things. This is a 60-year-old postmenopausal female with a primary tumor size of 7.9, stage 2B cancer, and on and on. So these are the information that Watson has learned from breast cancer doctors at Memorial Sloan Kettering as being relevant. It also points out things here that has not been collected, that wasn't in the patient record, wasn't in the EMR. This is in some cases these will be required. I mean, Watson won't even make a determination unless something is entered there. But usually they're optional, which might incline a physician to go off and run some additional tests. But in this case, there was enough information for Watson to come up with a treatment plan. And the ones in green here, first of all, clinical trials, everyone should always, any cancer patient should always look at a clinical trial first. So it always comes up first. But then there's a treatment plan for chemotherapy, followed by surgery, followed by endocrine therapy. And then there's other plans which in a normal setting would be acceptable. According to the guidelines, they're acceptable. Because of the additional knowledge we've learned from MSK physicians and their historical view, they have collected additional information that says these are not appropriate. So if I look at this particular treatment plan, you can see that this says, it gives you a timeline here of if you choose this treatment plan, then we're looking at chemotherapy, followed by surgery, followed by many years of endocrine therapy, and then probably radiation. So it gives the physician and ultimately the patient a view of what they're looking forward to, or maybe they're not looking forward to that, but that's what this treatment would imply. Now, the idea here is we don't expect the physician using this to automatically take Watson's recommendation on this, or even MSK's recommendation for that matter. This is giving a point of view. So it's as if you're talking to, in this case, an MSK physician, say, well, what would you do with this case? And if you want more information, so the top recommendation is dose-dense AC followed by paclitaxel. I want more evidence for why that is. Why did you choose that? Why should I? That's not something I would have given. I would have given something else. Convince me that this is the right treatment. So this is what it does. It gives it the rationale. This treatment is recommended as neoadjuvant care therapy when the tumor is HER2 negative. Remember, this is a HER2 negative, so it's taking in the genetic aspects of this patient. It's also listing curated articles that MSK physicians use. These are the set of articles that they use to convince themselves that this is the right treatment option. Secondly, there's additional publications that Watson found in the literature that would support giving this treatment option for this particular patient with these characteristics. So we're trying to give you all of the information, all the literature, all the evidence, rationale for why you should pick that. Also looking to provide information about dosage, and these are just suggested at this point. But again, the idea is to give you the information you have so that you don't have to keep all this information in your head. Some of the other things, well, maybe instead I want aromatase therapy. I can look at those and what's the rationale there. Aromatase inhibitors are recommended for postmenopausal breast cancer patients, and hormone therapy in general is recommended for ER-positive and PR-positive breast cancer patients. So it's giving me more information. If I want to dig in more, there's additional information here. Maybe tamoxifen. Notice that tamoxifen is in red here. Well, normally I would have given tamoxifen. By the way, all of the treatment options here are okay according to the NCCN guidelines. But with the information that MSK uses, some of them are not recommended. So in this case, it's saying there's both supporting and non-supporting rationale. So tamoxifen is appropriate for postmenopausal breast cancer, but most postmenopausal breast cancer should receive aromatase inhibitors over tamoxifen. So again, it's giving you all the information that you need to make those decisions. And then finally, once you decide what treatment options you're going to give, you can export that or print it for the physician to use, or something that you can hand to the patient that gives them all the characteristics of your disease, the timeline, the supporting evidence, and things like that. So you can see how it's taken a lot of the burden away from the doctor. However, it hasn't forced the doctor. You're not required to do that. The doctor is still responsible for their own recommendations, but they have all this evidence now at their fingertips that they can make those decisions. So I think, unless you have any other comments, Paul, we've got a few minutes for questions.
We have 3 or 4 minutes for questions.
For 3 short questions. So if anybody has any questions, I'll come out to you with the microphone. Oh, she's like, me? I got a question. And that's right, you gotta do it.
So I'm a faculty at FIU in computer science, and I have a question. Your Jeopardy show, Watson was talking, right, and answering questions that it understood. And I was wondering if you're interested also in computer-based interventions for patients via natural language.
Absolutely. I mean, this is part of what makes this work. It's an enormously powerful natural language processor. It understands human language, and even not only understands human language, but the subtleties of human language, to the point where it could get at the Jeopardy questions. And tremendous amount of effort has been spent in quote unquote medical school to get it to understand medicalese and our language in medicine. So that's part of the power of it. But I think that's probably the answer to that.
I guess the only thing I would add is that in addition to just being able to speak to it and have it speak back, we want to have a dialogue. So it's supposed to be an interactive approach. So based on what your question, it might ask you questions back. You can see some of that here. Based on this, I might ask you for additional information about this patient based on what options you picked and things like that. So it's supposed to be a dialogue also.
And specifically, the most common human error we make in our diagnosis is that we tend to, quite early in the process of deciding which direction to go, make a decision and follow that path and not look at other pathways that could go down. And so what Watson does is it forces it always back to the beginning. So if you ask a question again, it's not going to take you from where you are and go forward. It's going to go back and re-look at the world's literature, including the stuff that was just published yesterday, and re-ask the question. So we would eliminate that bias.
With regard to IBM making Watson available as a cloud service, how would a startup company or a professor in a research lab arrange to get access to Watson, if at all?
Yes, so there's multiple ways you can do that. I mean, we make Watson, if you're a development organization and you actually want to create a custom version of Watson, think of it as software development kit for Watson, so that you can actually take the core piece of Watson and you can extend it however you want. If, however, what you're trying to do already fits into one of the things that we work on, then you become a user of that, you become an instance of that. So we have a whole marketing and lab services organization that's there to help customers start to use Watson. So if you go to our website, I don't have it offhand right now, but you'll see those. You look at the Watson ecosystem, and it should give you the addresses you need to be able to make contact with our marketing organization to do that.
It's great. Thank you all for the questions. Thank you so much, gentlemen, for the great panel, the great information.